for the water resilience, to keep the water quality. And now we are going to talk to deal with the topic of the nitrate pollution from agricultural sources. And next speaker is Elisa Ferrari.
So, good morning, everyone. I'm Elisa Ferrari, and I'm an hydrogeologist of the irrigation community of Campo de Cartagena in the region of Murcia. And here, I'm also a project collaborator for the Clepsydra project, where we are actually assessing the water quality degradation. But before I start talking about the project itself, I would like to give an overview of what do we mean when we're talking about groundwater pollutions and quality. Well, when we're talking about groundwater, we're referring to both the unsaturated and the saturated part of the soil. And this represents a strategic freshwater resource. Mostly, the saturated part of the soil can supply water even in time of drought, and we can use it for multiple scopes, such as irrigation, drinking purposes, or industrial processes. And when not contaminated, it could have also a high quality. That's why we must protect this resource, because it's very vulnerable for two reasons mostly. Because of the slow recharge of the aquifer, and because if not proper managed, it can run out easily. So if we take into account the water mass balance, we know that from the precipitation splits in three components: the runoff, the evapotranspiration, and the infiltration. Of these three, just the infiltration part can eventually reach the aquifer. And during these processes and during the infiltration, while water percolates through the unsaturated part of the soil, it can interact with this and also with the rocks that are inside. So these processes give to the water its quality. But what do we mean when we're talking about quality of water? Where we're not talking about smell, or not just about smell, taste, or color. We're talking about a complex of chemical, physical, and biochemical characteristics which determine its suitability for a specific use. That means that there's no good or bad quality of water without before identify the context and the scope of that. The parameters that we analyze to assess the quality of water for a certain scope are those you can see on that table, which is the cations, colloids, or anions, salts, and moreover, we also analyze the temperature or the electroconductivity of the water itself, plus the component of pollutions, so heavy metals, NAPL or inorganic compounds, and so on. So let's see now those two different water cycles and compare those two. For example, in the urban water cycle, when the precipitation occurs, there are multiple surface unpermeable, such as roads, building, or roof, which not let enough infiltration, and less infiltration means less recharge for the aquifer. By contrast, in the agricultural water cycle, the infiltration will increase, and it could sum up to the irrigation water as well. So we have more infiltration, more recharge, but at the same time, water during the percolation can, as I said before, interact with all the substances present in the soil. And the big issue that we are affording with Clepsydra project in our 4 pilot sites is exactly that issue with nitrates, which is are inside the irrigation water and the soil beneath the crops. Well, the issue with nitrates is that basically they always prefer the liquid phase because of their high solubility and their negative charge of the molecule, which usually repulse with other negative charge of the molecule in the soils. And moreover, once they enter with water inside the unsaturated part of the soil, they can persist here for decades. Also, because here can occur different processes such as the hydrodynamic dispersion that can speed up the concentration. So the main issues that we are affording is that basically it's very complicated to assess and protect something that we cannot directly see. But what we can see are the direct consequences of that issues, such as human health or environmental alteration, like the phenomena, for example, of eutrophication, when a water is too charged with a high content of nutrients, can occur this phenomena, which basically happens a bloom of algae, and when those algae die, the species sharing the same biosphere are not enough to properly consume this organic matter, and this causes a loss of oxygen, and they compromise the life of all the other organisms living in the same sphere. So, and then last but not least is the issue with the aquifer alteration, which is the main topic of the 4 pilot sites of Clepsydra project in Lisbon, Campo de Cartagena, Barcelona, and Malta as well, because, as I said, when the aquifer is already contaminated, its recovery is very complicated. But once again, what we mean by contamination, we mean whatever concentration, alteration of concentration with respect to the natural environmental conditions. And it could also involve alteration of salt concentrations, whether radioactivity of the water or temperature as well. So this issue sums up with a semi-arid climate in a dynamic climate with an increasing temperature, increasing evapotranspiration, and everything concurs to a bigger impact on the pilot sites and in general. So the main solution that we are working on is to try to make the invisible visible. So we should stop acting just after the consequences are already evident, and we should start before. And how we can do that will a better monitoring network and better monitoring both the unsaturated and the saturated zone. That's why, when we did an inventory in our project, we figured out that the data that are available are not enough to properly manage the situation, and mostly of the data that we usually analyze are about just the saturated part of the aquifer, and that means that once we figure it out that the contamination is inside the aquifer, well, the situation is complicated to resolve. So we have to act before this aquifer enters the saturated part. So that's why Clepsydra project was born, and the main objective, in fact, are to do of improving groundwater monitoring and to develop a decision support system tool. And then we're going to test all the solutions that we are developing so far. And we are 9 partners in total and 4 pilot sites. This is an Interreg Euromit funded project with more than 2 million euros to invest for that purposes. And this is a table that shows the structure of our project. These are 4 working packages. Each of that has several activities. In each activities, we have a leader partner responsible for coordinating the others. This is a focus on a few of the activities that are already completed or still ongoing. For example, in the work package number 1, it's about reaching general public and about dissemination. So we organize periodic reunion every 6 months with our stakeholders, and those are called the Local Living Lab. And we share our progresses and we exchange ideas. Then I will focus later on the groundwater open day, but basically are days of dissemination on aquifers. On the work package number 2, the main focus is on data in general, So we are going to develop a new sampling protocol and the connected decision support system. Of these tasks specifically are responsible is responsible the Italian team from University of Cassino. On the work package number 3, we are actually going to improve practically the new probes and new sensor, or whether drilling new wells or new boreholes, and to implement new control points in the 4 pilot sites. And then the last activity is the social hydrogeological analysis, on which I will focus a bit later. So the first issue we've struggled with so far was with data and with representativeness of that, because the currently data are unreliable, and those prevents for an effective monitoring of the aquifer in general. By contrast, of course, representative data allow for a proper study of the groundwater. So what do we mean? What we intend to do is to collect accurate data, consistency, data set, and a proper coverage of the full area to better interpret what is going on there inside the aquifer, and to proper assess all the phenomena that are occurring, such as the pollution, recharge, or also exploitation of water. So what do we mean by weak data? We mean data that are fragmented, that are poor or incorrect, and those prevents for a proper interpretation, even for experts. So that's why we have this task of rewrite and redact a new sampling protocol, because maybe improving the methods of collecting samples of water, maybe we can improve also the data and the successive analysis in the laboratory, and reduce the errors that are occurring right now. As about the unsaturated zone, well, also Clepsydra project is about exchanges good practices between partners. So since our Malta partner already has implemented a Vadose zone monitoring system, we think it could be a good idea to implement these probes here as well. And this focus only on the unsaturated part of the soil. This is about probes with 2 flexible sleeves, and has several ports at different depth, and this allow to collect samples of water and gases at different level of the soil. It can be representative of the specific part. Moreover, those sleeves also have sensors that can provide real-time data on temperature and humidity of the soil. We have already selected a place where to implement this one, and our idea is to place one borehole beneath a citric crop, and the other one beneath the lettuce crop, to make a comparison of that, and to see how the water quality in the unsaturated zone change with respect to the thickness of the root zone and the kind of crop. Then the decision support system will be an application or a tool that will allow for informed and sustainable decision, and is supposed to be a friendly tool for the water users, and in that way they could better protect and manage the groundwater. And we're going to do that with artificial intelligence algorithm. Basically, what the team of Cassino is doing is analyzing historical data on groundwater fluctuation, and using this in the pre-processing phase of the model. Then they use this data to train the model, and they try to do different forecasts of scenarios of how this groundwater would change. And they also put in relation the fluctuation of groundwater with respect to precipitation data set as an exogenous variable. And in this way, what we have achieved right now is a forecast of 15 days ahead. That means that now we can say in 15 days, more or less with a good accuracy and a few errors, where is going to arrive the groundwater level with respect to the precipitation. But I want to make as well a disclaimer, because machine learning, it's not a crystal ball wizard. So once again, if data are not good or not enough or not solid enough, that cannot provide any useful information and not even reliable, because it will not be representative of the situation. Then those two activities are about reaching out to general public. It's the groundwater open day. Every partner organized at least one day of dissemination of aquifer, where we teach. In our case, we met with students at the university and also on the field, and we showed them all the instruments, all the tools that we used to use to monitor the aquifer, and what does mean monitoring campaign on field. And on the other side, the social hydrogeological analysis lead us to interview general public and not, meaning experts, but as well as students. And the main question, the main theme was about understand how the perception on groundwater and on aquifers have changed so far. So those are just some of the photos or the activities that all partners has developed until now, all about dissemination. But at the same time, we've also learned, analyzing data, that it's always better to know, to better understand, to proper face with the water quality degradation. Because maybe groundwater is invisible to many people, but the consequences are not. And that's it. Basically, the irrigation, the agriculture, the idea is that the agriculture can accede to this application and can monitor the input, the input irrigation. I mean, the water, the quantity of water or the duration of the irrigation processes with respect to their location in the map. And no, it's about quantity. It's about quantity.
This system, this system is complementary that we saw yesterday in Widok, because her work is dedicated to study the influence of the agricultural activity in the aquifer. In this case, she is studying from the hydrogeological prospect. In the system that we saw yesterday, we are only studying the leachates. The content of the leachates at the moment is very complicated to control. And at the moment, it's not what we are studying.
Anyway, mostly of the agricultural areas here are irrigated with drop irrigation, so it's already well controlled. Yeah.
Any other questions? Then we can pass to the last the last presentation of today, David Martinez Vicente.